Welcome to Germ Study Learn YouTube channel. Today we will continue our lesson part 3, and part 3 is the ending to hydroxy compounds. So in this part 3 lessons, we will focus mainly on phenol. We will discuss cumene process, phenol reactions, phenol esterification. Make sure to follow along carefully as phenol is an important compound in organic chemistry with many applications in real life and industry. Let's get started. Let's look into the phenol cumene process. First step about Fiedel-Crafts alkylation. The cumene process is the most common industrial method to make phenol. This is used in plastic, resin, and etc., and acetone, a solvent. It starts from benzene and propane, which are cheap and easily available. The reactants is benzene, propane, and acid catalyst, which is when benzene reacts with propane to produce cumene. So the product is cumene and is also called isopropyl benzene, which is just benzene with an isopropyl group attached. And we take benzene, a ring-shaped molecule, a stick, a propane piece, onto it using an acid to help. And the result is cumene, which look like benzene with a branch. And step 2, we have the oxidation of cumene, where cumene react with oxygen from the air to form cumene hydroperoxide, a kind of unstable immediate. The cumene react with oxygen to produce cumene hydroperoxide. And we add oxygen to cumene. The oxygen attached in such a way that we get a new group, so-called hydroperoxide, which is dash OOH on the side, and it is a bit unstable and ready to break down. And the step 3 is the acid catalyst, is so-called decomposition and rearrangement. When we treat cumene hydroperoxide with acid, it breaks apart, rearranges into phenol and acetone. So when cumene hydroperoxide, when there is the decomposition and rearrange of phenol and acetone. As a result, from acid catalyzed, it becomes phenol, and which is used in a plastic like bakelite, acetone used as a solvent, nail polish or remover. And this unstable cumene hydroperoxide falls apart in acid, and one piece becomes phenol, a benzene ring with an OH group, and the other becomes acetone, a simple solvent. Let's look into what kind of the phenol reactions. In this, we brought forward about the phenol reactions with sodium hydroxide and electrophilic substitution reactions of phenol, and also the reactions with the concentrated HNO3. Let's look one by one and see what is the result and the use test. So in detail part, we did describe in this presentation, and also we provide you with the summarization. Okay, so for the reaction of phenol with sodium hydroxide is to form sodium phenoxide and water. So in terms of the chemical reactions is we did display here where phenol is slightly acidic, unlike alcohol. So when it meets with sodium hydroxide, a base, it reacts to form a salt, which is called sodium phenoxide and water. And alcohol like ethanol do not react with sodium hydroxide. And this way because they are not acidic enough. In terms of the chemical test to differentiate alcohol and phenol, so phenol react with sodium hydroxide to form sodium phenoxide, which is dissolved, form a clear solution. Meanwhile, alcohol, no visible reactions with sodium hydroxide. Why? Because phenol has a slightly acidic -OH group due to the aromatic ring, which stabilizes the negative charge on the oxygen after losing hydrogen. So alcohol don't have this stabilization, so they don't react with sodium hydroxide. Then we look into the process of the chemical reactions about the electrophilic substitution reactions of phenol, where phenol benzene ring is highly reactive towards electrophiles because the negative OH group activates the ring, especially at the auto and para position. In terms of the bromination, reactions with Br2 in water, phenol react with Br2 to form 2,4,6-3,3-brometophenol white precipitate and no catalyst needed. The reactions is very fast because phenol is highly reactive. And in order to get monobromination, you only add one Br added. So use Br2 in a non-polar solvent like CS2 or with a FeBr3 catalyst to control the reactions. So phenol ring is a very reactive. So if you just add bromine, you get 3 bromines added white solid form. But if you want to control it and add just 1 bromine, you need a solvent like CS2 or a catalyst like FeBr3 to slow it down and diurite it. And reactions, the third reactions is when ethanol reactions with concentrated phenol reactions with concentrated HNO3. So we have here the reactions when phenol react with concentrated HNO3, it form 2,4,6, 3-nitrophenol, which mean that ferric acid. And for the test for phenol, when phenol is treated with concentrated nitric acid, a yellow precipitate form, and this is the prussic acid, which is so-called 2,4,6-3-nitrophenol. So if you add concentrated nitric acid to phenol, it reacts strongly and give a yellow solid, which is 3-nitrophenol. And this doesn't happen with alcohol, so it is a good test to check if a substance is phenol. So this part is a summarization which include the result from the reactions and also the test. Let's look into the phenol esterification. Esterification of phenol with acid chloride. Phenol is a compound with N-OH hydroxylic group attached to a benzene ring. So when phenol react with an acid chloride, a strong type of acid derivative form an ester. And what is actually happened is think of phenol as a sticky molecule because of the negative OH group. So acid chloride is like another sticky molecule with a part that can be replaced. So when you mix them together, usually with a base like NaOH to help, the two molecules combine and the negative OH is replaced, forming a new sweet smelling compound called ester. So when the phenol react with the acid chloride, it will form phenyl ester plus HCl byproduct. And test for phenol is iron 3 chloride. So phenol will reacts with a sodium of iron 3 chloride, and this reaction produce a purple-violet color solution. And what is actually going on? The iron grabs onto the phenol molecule, forming a complex compound. And this new compound reflects light in a way that makes the solution look like purple. So below is the summarization from what I already explained above. And that's all for today's presentations. Hope you will explain. So don't forget to subscribe to Germ Study Lab YouTube channel, and wish you all the best in your studies and upcoming examination. Thank you very much.